Hello everyone, my name is Satyesh, and in this video we will talk about an assignment for data analytics using R for Skyfi Labs online course. So in this assignment we'll start with data manipulation and then we will move towards data visualization using R. So we'll try to look into 80% of the functions that were discussed in the lecture. So I tried my best to cover almost everything which has been discussed in data manipulation topic and partially in data visualization topic in the lecture. So for data manipulation, we'll be using existing data set called MPG or miles per gallon data set. So this data set includes information about the fuel economy of the car models in 1999 and 2008. So, but make sure that these libraries are installed as per the steps described in the lecture. We have to import the library dplyr and ggplot2. So first thing first, we'll import the library ggplot2, which we can do by writing library ggplot2 and then library dplyr. Then I will press control enter and then again control enter, and then we'll use view mpg to view the mpg dataset. So as you can see that we have 11 observations here. So the names of the columns are self-explanatory. For example, who is the manufacturer, what's the model, what's the displacement, in which year, what's the number of cylinder, whether the transmission is automatic or manual, whether the drive, whether it is a front drive, whether it is a four-wheel drive, whether, and this is a city mileage, this is the highway mileage, and then this is the fuel, which type of fuel we have. For example, P is P equal to premium, and then R is equal to regular, and then we have one another. D is for diesel, and then we have C is for CNG, and E is for ethanol. And then we at last we have one another observation, class. So for which what kind of car it is, whether it is a compact or whether it's an SUV or whether it's a two-seater. So the names are self-explanatory. So let's move forward. So this data set has total 234 observations of 11 variables. So let's talk about the first function which we have discussed in data manipulation, which is summarize. Summarize is used to count the number of observations and store it in a column variable. Store it in a count variables. So for example, if we want to find the mean of the displacement here, okay, so we can write here the summarize mpg count equal to n and the mean displacement equal to mean and for the displacement, and here I have added na.rm equal to true, which means that if this displacement column has any value having na, then it will not consider that for the calculation. Let's see what's the result. When we do that, we can see that number of the counts, so the total number of observation, a total number of rows are 234 and the mean displacement is 3.47. But then the question arises that why we want to use summarize function if we have a more robust summary function. So to answer that, we have to understand group by function. Now the summarize function becomes very powerful when it is combined with the group by function. So for example, let's say that we want to know the city and highway mean mileage for different cylinder engine. So our goal is to find that what's the mean mileage in the city and highway for a 4-cylinder engine, for a 5-cylinder engine, for a 6-cylinder engine, for an and for an 8-cylinder engine. So how can we do that? So for that, we have to first use a function called group by. So we have written group by cylinder and group by, and then this is the data set and by which column you want to group it. So we want to group it by cylinder. Let's do that. Control enter, and then let's see the calculate the mean of the city. Now we want to calculate the mean of the city and highway mileage based on the number of cylinders in a car. Now let's see what's the result. So as you can see the result here, for 4-cylinder engine, the mean of the city mileage is 21 and the highway mileage is 28.8. So you can see that as the number of cylinder increases, the mean of the city mileage and the highway mileage decreases. Exception being the 5-cylinder engine, in which the highway mileage is almost same. So you can see here that when we have used this with group by function, when we are used summarize with the group by function, then it has become more powerful, and it can use to manipulate data in a much better way. So let's move to another function called summarize at. So in summarize at, it basically summarizes at a specific columns. So summarizes means it summarizes mean and median. For example, our use case is to summarize the mean and median of city and highway mileage of cars. So I have written summarize at mpg, then which columns you want to summarize. Then I want to summarize the city and the highway, and then here I have given a list of mean equal to mean and then median equal to median. Let's do that, and then you can see here that the city mean is 16.9 and the highway mean is 23.4, and the city median is 17 and the highway median is 24. So you can see here that uh, one second, Control L, yeah. Okay, so you can see here again, this can be used in a combination with group by, then it will be really, really powerful. For example, if I do this and then press here, then you can see that for 4 cylinder, 5 cylinder, 6 cylinder, and 8 cylinder, what is the city mean, what is the highway mean, what is the city median, and what is the highway median. So now let's move to another function called summarize if. So it summarizes the columns conditionally, but we have to be very, very careful here. Now summarize if is has will take one parameter as the data set, and then what is the your condition here, but it only takes the only apply a predicate function, which means that a function that returns true or false to determine the relevant subset of columns. So for example, it will go to this data set mpg, and then it will find that which all columns are numeric, and if the columns are numeric, then it will find the mean of that particular column. So for example, now in mpg we have displacement as numeric, we have cylinder as numeric, we have drive as numeric. So let's see what exactly it gives us. So when you do this, you see this displacement, year, cylinder, city, and highway. So all those columns which were numeric, it has given the mean of those columns. Now let's move to another function called summarize all. So it allows us to summarize all the variables. So when we give this summarize all mpg city function mean and median, so what it will do that it will find the it will go to this column, and then you can do whatever you want to perform on this particular column. Let's say that I want to find the mean, I want to find the median of this particular column, then I will simply write summarize all, I will give the variable name, and then I will press Control Enter, and you can see here the mean and the median of that particular column. So you can also increase the functions which you want to operate on this particular column. And let's move to another function called summary. So summary has been already explained in the lecture. So when we give this summary mpg, then it will give us the entire summary, and I will not explain that what each of the what's this result mean, because it has already explained in the lecture. Now let's move to the group by. Group by I have already explained above. Please see section 1. For example, here I have given another example. If we want to group our data set in terms of that who is the manufacturer of that particular car, then I have written group by maker, and then I have given the data set, and then I have given the data given the column. And then when I'll click summarize, so when I'll do this, then when I do this, you see here the summarize. So we have this Audi, and you can see the mean of the Audi car. I mean city highway, city mean of the Audi car, and then the highway mean of the Audi car. So you can see the best mileage in the city will be given by Honda. Yes. And also on the highway, the best mileage is for Honda. So you can see here means we can easily play around with our data set using group by. I recommend you all to use group by because this is a really cool function and really important. So let's see what's ungroup means. So this ungroup the data set which are grouped by function group by. So let's say that if you have, if for example I have already grouped by cylinder, and I have done that, and and then I have added a new column by using mutate. So let's see that I have added a new column. So you can see here I have added a new column. And if I want to ungroup now, then I will do ungroup, and then this column will be gone. So whatever you have grouped by group by, you can ungroup it using ungroup. Now let's move to another function called filter. So in filter, it has been already explained in the class. So it extracts rows that matches the logical criteria. So let's say that our use case is that filter Audi car having city mileage greater than 15 and highway mileage greater than 20. So I'll give filter, then I'll give the data set, then I'll give the first condition, city should be greater than 18, and I'll give the second condition, highway should be greater than 20, and then I'll give the manufacturer, who is the manufacturer, Audi. So it's a kind of logical AND operation. So it will check 18 and 20 and Audi. And then when we do this, and then when we see fill, you can see here that we found 5 cars of Audi which has more city mileage, which has a city mileage more than what was our use case, more than 15, and highway mileage more than 20. Okay, so let's move to the next, distinct. So in distinct, it calculates the unique value of a column or a variable. So let's say that if I want to know that in our data set, how many car manufacturer are present. So we'll write distinct, and then we'll give the data set, and then we'll give the column name. When we do this, then we can see that, okay, we have total 15 car manufacturer, Audi, Chevrolet, Dodge, and so on. Okay, then now let's move to another function called sample frac. So in sample frac, it randomly selects sample from the data set. So it has also been explained in the lecture. So let's say that to select 10% of the data, we'll write 10%. So I have defined a new variable called 10%, and then I'll write sample fraction. Then I'll give the data set, and then I'll give 0.1. So 0.1 means 10%. So the value of this parameter lies between 0 to 1. And when I do this, then it will have, so we'll have this 10% having, so this 10 PCT will have 10% of our original data set. So our original data set had 234 observations. So now 10% of that, we have 23 observations. Similarly, for the sample n, so sample n will randomly select the number of rows from the data set. And let's say that if I want random rows, then we'll simply use sample n, and then we'll give the data set, and then how many number of rows we want to access. So we have sample n mpg and 10. So when we do this, then we'll have this random rows having 10 observations. Now let's move to another function called slice. So in slice, it select the rows by position provided. So example, it will extract 10 rows starting from 14th row. That's if my use case is that to extract 10 rows starting from 14th row, then I will write slice, then I'll write data set, and then from where to where you want to access. Then I'll do this, and then you can see here that we have the 10 rows from 14, starting from 14th till row 23. Now this top n is also an important function which I will recommend, because top n select the top or bottom entries in each group ordered by weight. So let's say that if we want to know, filter it is, let's say that if you want to filter the top 5 entries of car having largest displacement, then we'll simply write to I'll define a variable top display, and then top n, then data set, and then how many entries you want, and then what's the column observation. So we'll do this, and when we have given here, and let's see the top displacement. So you can see here the top displacement. So this is 6.2. This is the top displacement is Chevrolet Convet, and then Jeep Grand, yeah, Grand Cherokee, I guess, forward. And let's say that if you want to have five entries of bottom five entries of car having the smallest displacement, then you just have to replace 5 by -5, and then you can just write it, press Control Enter, and then we can go to bottom displacement, and you can see here we have all cars from Honda, only entries from Honda. Now let's move to another function called arrange. So arrange specified columns in ascending or descending order. Now in arrange, let's say that if you want to, you can see here this top displacement, it is not arranged in any order, 6.2, 7.0, 6.5, 6.1. So let's see that if we want to arrange top displacement in descending order, then we'll simply write this arrange top displacement, descending displacement, and then you can see here that it has arranged it. Similarly, for the bottom displacement, if you will not specify DESC, then it will automatically arrange that in ascending order. So let's say you see you have arranged it in displacement in an ascending order. Now let's move to another function called pull. Now pull a specified column. So it will fetch observation manufacturer from dataset MPG. So let's say that pull MPG and manufacturer. So it will pull the manufacturer, observation manufacturer from dataset MPG. So what will happen? So you can see we have 234 entry and all the, so it has extracted one particular column. Then let's move to select. Select is also an important function, and it the pull while pull extract a particular specified column, we can use select to specified columns. It's plural. So let's say that if you want to extract columns manufacturer, cylinder, and city, and I will do a head because I want only top few entries. So let's do that. So you can see here that on the enter manufacturer, cylinder, and city, it has been so we have extracted all these columns. Now let's move to another function called mutate. So mutate compute new column as a function of one or more column. Let's say that we have to add one new column, and let's say that that is a ratio of city versus cylinder, city highway versus cylinder. So I will write mpg1. I've created a new data set, and then I have created a new function, created this use this function mutate, and then you can see here, and then I will do this, and you can see we have a new column added called ratio. Now let's see, we have another function called transmute, and now transmute and mutate. So there is a slight difference between mutate and transmute. Transmute will compute new column and only display new column. So I have created a new data set, and I have used transmute, and then I have created ratio. But when I will do this, and then when I will view the data set, it has only one column which is newly added. So that's the basic difference between mutate and transmute. Now let's move to another function called rename. So in rename, we have it as the name suggests, it will rename the existing column. So let's say that our use case is rename column cylinder to sill to cylinder. So I will use mpg1 and I'll rename mpg, and then here it's kind of opposite. So you can see here that cylinder is the old name of the column, sill is the old name of the column, and cylinder is the new name of the column which you want to be. So we have to write this, and then when we view, you can see here sill has been replaced with cylinder. So the data manipulation uh, chapter as discussed in the lecture ends here. So I believe that I have covered almost everything which has been covered in data manipulation, almost every function. I think I have not covered one function called add row, as far as I think so. So let's move to now data visualization. Okay, so let's discuss data visualization. So we'll discuss about data visualization here, and we have to again import library dplyr and ggplot2. I have also imported library coregram, coreplot, and lubridate. So basically coregram and coreplot is for finding the correlation, and lubridate is to for converting the date in a for converting the format of the date in date format. So basically I believe that when we import any data set, and if it has date, then it might not be in a format of date. So although it will look like it's in a format of date, but it might be a string. So if you want to convert that in a proper format of date, then we have to use this function lubridate, use this library called lubridate. So for this assignment, we'll use a data set of corona cases in India till 25th May 2020, and we'll see how the cases in Bihar has behaved, and what was the correlation between the confirmed cases and the patient cured. And we'll also see different ways to visualize the data. So first thing first, we'll import library. So let me clear this console. Okay, so I'll import library dplyr, ggplot2. So I'll import all the libraries. So now I have two data sets which I'm reading via read.csv function. So I have one data set which has a state-wise testing detail.csv. So let's read that, and then cases db. So, and let's see what's inside this. So first I can close all these. Okay, so in test db database we have one column called date, and then state, then total samples, then negative, and then positive. Okay, so I think I have closed data visualization. One second. Okay, so let's see what's inside view cases DB. So here we have a serial number which we'll remove later. Then we have a date, and then we have time, then which state, and then who's confirmed international. But we don't need all these things. We need cured, how many patients were cured, what's the total number of death, what were the total confirmed cases. So we'll see. Let's say that we want to filter the cases of Bihar occurred on each date. Let's say that. So we will use the filter function, and we'll use this command filter, and then we'll give the database a data set, and then state.union territory, because that's our column name in cases db. So you see state.union territory is, so we'll give that as Bihar, and then we'll filter it. Okay, and then let's try to see what's the our Bihar case db. So you see all the number of cases in Bihar have came here. So it has total 65 observations of 9 variables. Okay, so now we want to filter number of tests that were conducted in Bihar on each date. So we will use another data set, test db, and then similarly we will view now this. So you can see that what was the total number of samples which were taken, negative and positive, and everything in the state Bihar. Okay, so now what I want to do before performing any kind of data visualization, I want to make a combined data set. Let's say that I want a one data set which is a combination of cases Bihar test db and Bihar cases db on the basis of dates. So for example, if we have data as 5/4/2020, and if I open, so let's say that okay, on 5th of April, so this is common in both the data set. So on 5th of April, total samples were taken was 3037, and the positive were 32 and negative were 2299. So, and in Bihar case db, we have this 5 4 from on 5th of April 2020, total confirmed cases were 30. So I want one data set which will have which can be joined using the column date. So for that, so I'll write merge these two data sets so that we can get a combined data set which shows the number of cases found on each date. Also, this data set will show number of tests conducted on each date. So the common observation in both data set is date. We will combine the data set on the basis of date. This means if the date is same in both data set, then combine Bihar case DB and Bihar test DB. Let's see how we can do that. So although this has not been explained in the lecture, but I thought that it might be helpful for someone who wants to do data visualization in a much detailed way. So what we can see here is that in Bihar case DB, the date has a different format. It's uh, it's date dd slash mm slash yy. But in Bihar test DB, we have a different data format, YYY hyphen mm hyphen dd. So if we want to make a new data set and combine combine Bihar test DB and Bihar case DB on the basis of this particular date, then we have to make sure that in both the data set, date should have the same format and same say a kind of same data type also, even though the data types will not be same, and if it is string or even if it will be string or something else, uh, then also we can combine it, but it might throw us a warning. So you can see here that the format of date in Bihar test DB is this, and then format of date in Bihar case DB is this. So we have to make the format same. How we can make this? So I have used this Bihar test DB column date. So you can see I am accessing column date, and then I'm using this function format, and please make the date so to y, so year, and then month and date. So earlier it was, so now it has year, month and date, but what I want is I want date, month and year, and instead of hyphen we want slash. So let's do that, and then the and now we can see here if we want to, let's access it, view behind test TV. Let's do that. So you can see that now we have date, then month, then year, but now also it's not same because we have 20 instead of 2020. So we will use another function called gsub to replace. So it will replace 2020 with 20. So how we can do that? So gsub, what you want to replace? I want to replace 2020 with what you want to replace? I want to replace it with 20, and then which column? So Bihar test DB and date. So let's do that. And now the format is same in both the data set. Let's view it. So you can see here Bihar test DB has 5420, and then Bihar case DB has this. Let's close this. Okay. And now here comes the lubricate. So to make the date column as date and not character, so I will convert the date column in Bihar case DB with, so I don't need this because I have already imported library. So let's import library lubricate. Let's do that. And if you will not do this, then we might end up in a warning. Okay. Now what I want to do, so I want to do a left join. I want to do a left join, and I want to combine Bihar case DB and Bihar test DB on the basis of date. So let's do that, and let's view it. So you see here that Bihar case DB. So on 5th of April, we have this total samples 3037. So both the data sets are combined now. And since the data were not there was no information about how many total number of samples were taken on 22nd of March. So it has filled it with NA. So I want to delete the redundant column state. So you can see here that we have state dot union territory here also and a state here also. So I want to delete it. So I can simply write that PRK select PRK DB and then minus state, and it will delete it. Then I also want to delete the columns confirmed Indian national, confirmed foreign national. I don't want, and then serial number. I don't want all this. So I will delete this. Okay, so now our data looks much neater. But I want to rename the column state.union territory to state because Bihar is a state. So let's do that. And now if I'll be okay, so you can see now it has been replaced with state. Okay. Now the dataset Bihar case DB is ready for visualizing. But to let's say that I have added one extra data manipulation topic here or function data manipulation use case here. So let's say that if I want to know that how many rows or how many rows have the value NA in total samples, how many is what's the total number of NA in this particular column total samples. So if I want to do that, then I can write summarize all, then I'll give the data set what, then I'll give the column name and then a function, and then I sum is dot na dot. So when I do that, you can see here that we have total 17 na values. This is just for more information. You can totally ignore it if you don't want it. Okay, now let's do a histogram plot. So for histogram plot, I have used the ggplot, and then I'll give the data set, then I'll give the aesthetics, and then what's the x-axis, then y-axis, and then fill. I want to fill it with number of deaths, and then I'll do. So this is as uh, as it has been explained in the lecture, we have several layers. So now this is our ggplot is just a basic data, and then we will add that what kind of plot we want to have. And here we have given stat is equal to identity, so statistics identity, and bin width is 2. So bin width is nothing but it's a kind of quantization. So let's say that if I have given value equal to 2, then it means that it will quantize in a form of let's in a form of if we have this bin width equal to 2, then it will quantize it with uh, let's say that we have a value as 5, then it will say that okay, so anything which will range below 2 is having this value, more than 5, okay, then that will have this value. So it is basically kind of quantization. Then I have given gg title, and then x lab, and then y lab, and then let's do this. When I do this, okay, so you can see here that in April, then 15th of April, then May, so number of deaths. So you can see that the number of deaths has been increased as the number of confirmed cases has also increased. Now again, let's say that if in this axis, if you want to have the dates should have a 5-day gap, then in that case what we can do is ggplot, then we can give this part will be same, then we'll have this group, then we'll date, then breaks equal to month, and the scale x date. This is an important function where we can give date breaks equal to 5-day. Let's see what happens when you do this. When you do this, then you see the first observation is on 3rd of May, 3rd of April, then the second observation is on 8th of April, then on 13th of April, and then you can see here. So these are the part. So just for your information. Then we'll move to point plot. So in point plot, we will do, so these things will be same, and then I'll do this geom point, and then I'll give color blue. Let's do that. You can see number of cases are increasing as the with the increasing number of date. Okay, so if we have a scatter plot with a lot of noise, it can be hard to see the dominant pattern. So in this case, it's useful to add a smoothed line to the plot with the geom smooth. So I'll do that, and you can see, and here you will see a warning, you will see a, a warning kind of thing which says that it has used the LOESS method to generate this smooth, generate this line. So you can also change the method here, and let's say that if you want the method to be LM, like linear model, then if you do that, then you can see that this is our linear model, this is how the case is. So you can see there was some negative, it's also in the negative axis. So we will stick to our old model, like the default model. And now we will use the point plot with facet. Now to visualize and to generate a facet plot, what I have done is then I have created a new column called month. So whatever, so I have added a new column called month here, and depending on the depending on this value, the middle value, it will fill that particular column. So we can see how we can do that. So let's say that mutate, I have added Bihar case db, then month equal to months. So this is an R inbuilt function months, and then it will automatically take Bihar case db and will give the column name. We'll do that, and when I have done that, then you see a new column has been added, month March, April, and then May. And now I will, so now we have this facet. So you can see the March, April, and May, and you can play around with this size. So I can give the size as 1 here, and then you can play around with the size to increase or decrease the width of the graph. Now we can also do the box plot. So ggplot Bihar case db AES state, and then we can write geom box plot, and it should create a box plot here with the total number of deaths. Then let's say that we want to find the correlation between number of confirmed cases and patient cured. And so this has been already discussed in the lecture. So we'll do a supply, and we will see that we will make that every column is numeric, and then code the data, and then we'll do the core plot here. And then you can see here that as the confirmed cases has increased, so there is a positive correlation between confirmed cases and the number of patients have been cured. So this was it for the with the perspective of the assignment. I hope you liked the video. Okay, thanks, have a nice day.